So here we're gonna talk a little bit more about domain and range of the function. Also, we're gonna talk about vertical test and a little bit more about function equations. So here's how the book's recommendation on how to find domain and range from its graph. It says to find the domain, look for all the inputs on the x-axis that correspond to points on the graph. And to find the range of a function from its graphs, um, look for all the outputs on the y-axis that correspond to points on the graph. That's very dandy, but what does it really mean? Well, basically, when you're looking for the domain, you're looking at how far does your graph stretch to the left and to the right, and are there any gaps? So that's your domain. For your range, same thing, only vertically. How far up and how low down does the graph go, and are there any gaps? So that's basically it. We're going to practice it. Let's practice it right now, and then we're going to talk more about it. Okay, so for example, this graph. Okay, so what's the domain? Domain. Well, so again, domain looks at how far to the left and to the right the graph is stretched. Well, to the left, it only goes up to -2, and to the right, it goes up to 1, right? So on the domain, on the x value, on the x-axis, your domain is right here between -2 and 1. And there is two ways to write it. One is interval notation. Interval based notation is basically describes an interval or a piece of line, and you describe the beginning point. You put the beginning point first, so it's from left to right. So the beginning point is -2 and the end point is 1. So uh, most books do it comma separated. I like the semicolon. Okay, and then you actually have to specify whether you're including these endpoints or not. So the solid dot right here indicates that the endpoint is included. So when it is included, you're going to put a square bracket by it. Now our the one is also included, so we would put a square bracket by it. But let's pretend for a second that it's not included, and we have an open space here, an open dot, which says this point is not included. Then you would put parenthesis by it. Okay, so let's go that route. Oh, actually, we have another example with that. Okay, but you got the idea. So that's your interval notation. Interval. But there is also what's called a set builder notation. So let's talk about set builder notation. So for the set builder notation, you're going to use inequalities. You're going to say my x is between -2 and 1. So, but you start with open figure bracket, and you're telling your audience that you're describing x such that the vertical line is read as such that in mathematics, and you're going to describe it now. So it's between your x is between -2 and a 1, and since we're including -2, we're going to put the equal sign as well. So it's less or equal to -2, but I mean greater, your x is greater or equal to -2, but it is less than 1 at the same time, and then you close the braces. So this is your set builder notation. And sorry guys, we kind of we're distracted from identifying domain and range right now, but you need to know how to use these different notations. Interval notations is mostly used, while set builder notation is also widely used, but not as widely as interval notation, but you have to know both. Okay, so let's describe the range now. So for the range, basically the range is how far down or up. So the range describes the vertical spread, okay? And the domain describes the horizontal spread for your function. So what's the vertical spread? Well, vertically, it only goes down, it starts from 0 and it goes up to 3. So that's your range. So the range in interval notation starts with 0 to 3. We include 0 and we do not include 3. That's the interval notation. Now the set builder notation. Open braces. We're describing y values now. So such that y's are from 0 to 3. And that's how you would do it in a set builder notation. Okay, so now I want you to try it yourself and try and describe the domain and range for this function, and I'll wait. All right, so hopefully you did that successfully. And I want to show you another example of a function. So not your functions sometimes consist of different pieces, and they will have gaps in them, like this function here. So when you're describing the domain for this function, domain, you're gonna glue two pieces together, right? So, well, first of all, what I want to mention is that sometimes students assume that the function goes only, for like the shown window, right? And that it stops there. But it's actually not always the case. A lot of functions will continue indefinitely, okay? And sometimes it's shown by putting arrows there and saying it goes on and on into this direction and then on into that direction. But sometimes they don't show that. They just show you a piece of a function, just this window, and they don't put the arrows to indicate that it goes on and on. So how do you know? Well, unless there is a dot there, a point there, a clearly marked end of the function, then you assume that it goes on forever. If like right here, they clearly marked the point where it ends, so we know it ends there. There, they didn't mark anything, so that means that it just goes on. Okay, just keep that in mind. So the question is, how far to the left does this function go? Well, it goes forever. They didn't tell us that it stops. So we're going to start with here, the forever on the left is negative infinity, and forever on the right is positive infinity. Okay, so we're going to say that this piece, so we're going to have two pieces glued together, right? So this piece, it starts from negative infinity, and where does it stop? Well, it stops right here. It looks like it's 1. So it goes from negative infinity to 1. Let's talk about parentheses versus brackets. So 1 is clearly included, right? So we put a bracket by it. But for negative infinity, here's the thing. We never include infinity because we don't know what it is. So if you have infinity in your interval, you're always going to put a parentheses by it. Okay. So this, let's continue. So this is one piece of the function, and then there is a gap, and the second piece starts with 2, right? So starts with 2, and again it goes into infinity. So it starts with a 2, and 2 is not included, so that's going to be a parenthesis by 2 and parenthesis by infinity. And then what you do, you put the sign that basically tells you this is one piece, this is one domain, okay, of this function. It consists of 2 separate pieces, but it's a one domain. And this is kind of like a U symbol. Okay, and actually this is a union sign, the union sign. So that glues those 2 pieces together. All right, and for the range, let's do this really quick. So for the range of this function, oh, well, actually it's interesting. I want you to think about this one. What would be the range? So the range is, as a reminder, how low to how tall this function goes. So the bottom point of the function is 0, and the tallest is infinity. Now the question is, does it interrupt? Are there any gaps? And the answer is no, there are no gaps in the range, because here's the gap, right? But it is covered on the other. The function still exists here. So if you look at the x values, there is nothing between 1 and 2. There is no function, right? But if you look vertically, if you scan like this, there is always a function somewhere, right? When you go up on the y-axis. So that's why we do not include the gap here. So the range is from 0, including 0, to infinity. All right, I hope this helps.